SMS 1309 loaded. And once again, I mentioned this earlier, but for those that may have come in late, USACE employees on an ACIT machine only have access to 1308. This particular feature is not available until they make available the 1309 or a later version. So what we're going to do is we have SMS loaded here. I have my folder. I'm going to go into Start Files and find the SMS project, bring it and drop it in, and I have this as a result. So I've got the grid. I've also got boundary conditions already specified. I have a flow, water surface elevation flow on either side just to get some currents moving. And then I've got my annotation down here, but nothing else. So you notice there's no D50, there's no Manning's in. I'm going to load those later, but for right now, this is what I wanted to start with. And so what the next thing that we would do is basically we want to create a new coverage, and it doesn't matter what type. So I'll just give it a name here, and I'll just call it DM zones, something like that. And then once that's selected, I can come in and create my two different zones. And so I'll just do these for right now, but I'll come back and actually load in a map file that's already got these created so that we're all consistent. And so what we're going to do is just say, okay, I want to dredge a channel from here to here, and it's going to look something like this. And then I make sure I close that back on itself, and then I can go under Feature Objects and Build Polygons. And then once that's there, I can double click on that and make sure that it is an enclosed polygon. We don't have to do anything as far as materials or anything like that right now. This is just going to be used to select the cells inside of this zone for editing later. All right, and then we're going to do the same thing down here and create a placement area. And you would do this wherever your particular project would be placing the material, whether it's near shore, an offshore placement area. You don't even have to have one of these. If you just need to dredge the material and get rid of it, say you're placing the material upland or something like that, and nothing that's going to be affected by your hydrodynamic simulation, you just wouldn't need this. You would just be dredging and the material would go away. So anyway, what we're going to do is I close that and also build polygons, make sure I can select it, and then we are ready to go. In my case, I'm going to bring in a map file that contains these already. So let me get rid of this real quick. I'll go over to my intermediate or my other needed files, and I'll bring in this zones. And so this already has the ones that I'm showing as part of this particular example. So I've got the two different zones. I need to make sure that they are built, so I can select them polygons. I think I mentioned that they need to be in separate coverages earlier, but I was mistaken. They can be in the same. Because like I said, we're just using this to select cells from the quad tree. All right, and so that's pretty much it. So now let's use these polygons and select those cells. So the way we do that is we will select the first one. Actually, let's, I'm getting a little bit ahead of myself. We need to create the different data sets for these two. So let's go to the quad tree, and then under Data Set Toolbox, there's a calculator. And so our first one we're going to do is just the dredge data set. And we're going to set a default value of -999, hit compute, then done. And you see it located over here on the left-hand side. We'll do the same thing again. We do a data set toolbox, calculator, We'll change the name of this one this time to be placement, have -999, compute, and we see it over here in the dredge data set. So now what we can do is, for each one of these zones, select the cells inside of there and then modify these values. So let's work on the dredge. We will come over to our map module, select that polygon, and then under feature objects, there is a select delete data. We can make sure we select inside the polygon for the quad tree. There's only cells available, and then we select the actual quad tree grid that we're working on and say OK. And then we can come in and see what cells are going to be selected. And so it's a little bit off from our zone that we have defined here. So if we needed to, we could either add these cells in one by one. You can hold your shift key down and then start selecting a few other cells. You could do the same thing and hit Control and Shift and actually draw an arrow and select a few other cells. You can do these at different times if you want. So set the values first and then come back and set a few more values. So that's basically the cells that we want to modify here. So we're going to change this S value from -999 to 6. And make sure you get rid of that negative sign because sometimes they're a little sticky. If you select something, it sometimes misses that minus sign. Let's select everything, get rid of it, and put a 6 in there. Hit enter, and then we see we've got these values modified. And so that has selected the cells that we need in our dredge module for dredging and given the value of 6 meters deep to be our trigger depth. All right, so the next thing we're going to do is the same thing for the placement area. So in this one, we're going to switch over to the placement. You see these have disappeared now. We go back to the map module, feature objects. Oh, I've got to select the polygon first. Feature objects, select and delete data. Select inside the polygon for the cells. Click OK. And we see that it's missing a few cells, so we're going to do like we did before and add those back to it. Oops. And then we have those selected, and we're going to modify the scalar value for that data set and make it 1. All right, and so as we showed before in the PowerPoint, we have the placement area with those values selected. We have the dredge data set with those values selected. And then we are good to go with the rest of our setup. And so what we want to do is right-click on the simulation that we've got everything loaded to, so that right now it's called Default Coverage Grid. You can name this simulation whatever you want. So I could change this to capital dredge event, something like that. This is one of the things that we went through, one of our examples for the CHETN, the technical note that we put out on this earlier this summer. And so you can name this whatever you want. Right-click on it, and instead of model control, you can go down and define the dredge module information. So it brings up this dialog, and you can turn this on or off. In your case, I think the default value is disabled normally, but just enable it so that you can modify the values. If it's not then you can't even get into the placement information either. So let's enable that, give it a name if you want. We want to select the dredge data set, so we go in here, click select the dredge data set. If you see that, click OK, and we notice it populated this field here. We choose a dredge method, so it's either the shallowest cell or a specified cell, and so you could choose either one you wanted. In our case, we're doing specified cell. And let me go over here and make sure I'm putting in the right values here. So by default, it would normally have 0. I pulled in a simulation. It's already got the number 5292, but that's not necessarily the right cell for me. So how do I find where that cell is? Let me just click OK for right now and get back to my grid. So for here, I want to start at this cell. And so I would select that cell in this location, and you come down to the bottom line here, and you see the ID for that cell is 5230. All right? And so you would just make note of that in your head. Okay, 5230. Then you can come over and modify these values again. So I'll put 5230 here. We're going to have a dredge rate of 10,000 cubic meters per day. You have several options here depending on what you want to do. So anyway, 10,000 meters cubed per day. Our trigger method we could either do by depth, a certain volume, percent, or time periods. So there's several different options here. And if you want to know a little bit more about each one of those, I would recommend going to the 2 technical notes that we have published on this. One was in 2016, I believe, which was the first covering of the dredge module with single grain sizes. And then we put one out this summer on multiple sediment grain sizes and covered a little bit these other examples. But I think everything was defined as far as how things are operated in that first technical note. And there is a little bit of information here. So when you have this selected as depth, you can see the note, dredging is triggered when the depth of a cell in the source area exceeds a depth threshold. So in this case, we're going to use a value of 6 meters. If we change this to volume, then of course it's a volume of sediment instead of a depth. And then percent, and certain percentage of cells in the source area exceed the threshold depth. So you can have several different ways of selecting this. We're going to do this particular case as depth. We're distributing it as a percentage. And as it says, all the placements must sum up to 100. There's some extra output that you can turn on or off if you need it. By default, it's off. So we've got that set. We can go over to placement definition now, and we will turn on placement area 1 and select the data set, which we're going to use to define that area. So that's placement. Click OK, and it shows up here. We can either place uniformly, or we can start at a specified cell. And so the difference, of course, is for uniform, it places a set amount of material over every cell and then gradually increases the thickness of the entire placement over time. With specific cell, it starts in one corner and it goes up to a certain thickness and then it moves to a different cell. So you may wind up with your entire area not completely covered. So in this case, we need to specify the starting ID for the cell. So let's go and look for that cell number. So we go over here to our placement area, and we will select this corner cell, and that number is 895 as it shows down on the bottom line. Go back into our dredge module definition, and make this 895. There's only one area that we are defining right now, so we make our distribution percentage 100%, and then our thickness is 1.1 meter thick. You could base it on depth if you want, but then you'd have to know, how far down from the water, surface of the water it is, things like that. So we're just going to say we want a thickness of 1.1 meters on that bottom for that placement, and that's it. If you have other areas, you can do the same thing for each one of those, but in our case, we just have the one. Make sure you click OK. And of course, as we mentioned earlier, you might want to save regularly. So you can file, save your project into another location. So for this case, we need to go ahead and set up the rest of our model control. So right-click on the simulation again and go into model control. And we're going to enter the values as we kind of mentioned in the presentation. So our start date and time, you would modify that. For us, our simulation duration is going to be 550 hours. And we specified ramp duration of 2 days. These are totally up to you. We're not going to have an initial conditions file. We're going to have a recurring hot start file every 48 hours. It's already defined right there. So we would use that. Choose the solution scheme. We're going to go with implicit. And you can change the number of threads if you want. In my case, I have some extras, so we go up to the maximum of 4. Under flow, we're going to modify what we need to. We need to set this bottom roughness set, but I don't have one created. So I'm going to wait for a minute and then pull those data sets in. But you would set this up exactly how you would want for your area, for your bottom friction. For our output, it automatically has a duration and increment specified, so I'm just going to leave that alone. But I will go down to these output data sets and make sure that a few things are turned on. So I'm going to turn on morphology change. You can turn on or off the actual change data set. By default, you are going to get the depth through time. And then you can turn on transport and turn on all of the different values that you might want to see. There's other options there that you might want to turn on, and you can change the simulation name if you want. Put whatever you want there so that when you pull the solutions in, you'll get a folder with that name, and you can differentiate that from a different solution. So we go to Sediment Transport, and I'm going to turn that on and then make a couple of changes here. So we're going to go with a size class of 0.2 millimeters. And then we're going to, for this case, we're enabling the simplified multiple grain size definitions. And I evidently had already had this set up. But when you would come in here by default, these would be empty. You would insert rows for the ones you want. And then I'm adding the values for the grain size as I specified in the notes. Standard deviation, we're going to set to 3. We're using the D50. I've got to come back and do the D50 data set. Bed layers, 5. Constant thickness of 0.2 for the mixing layer and bed layers. And then that's all we need to do there. So let me go back and pull in our bottom friction and our mannings in. So I just grab those two and pull them in. They are set up for this particular grid, so they actually load without a problem. If they were a different shape, geometry-wise, then you'd have to manually create your data sets and set the values. So anyway, let me go back into model control and set these up. So it automatically knows, it sees the mannings in, so it sets up a Manning's End for your bottom roughness. And then for sediment transport, it sees I have a D50, and so it sets that up as the D50 data set. And so I should be good. I click OK here. I will make sure I want to save the project. And so just for everybody, if you want to bring in a solution that will load, we can pull in the final files here, and I'll just do that real quick. So I'll kill this real quick and then pull in a previously saved example after I've already set up all this information. And so you see I have the D50, the Mannings, the different data sets, the dredge zones. Everything is already set up. Let me make sure my dredge module is set up correctly. It looks right there. That's fine. And then the model control. It looks fine as well. So I'll progress here, and then I'll just tell it to go. And so what I can do is right click, and so you can either save, export, and launch. In my case, they're already done and they're ready to go. So I will just launch. If I can click on the right location. All right. So let me launch. So it says CMS flow is running, and you can see that it's moving forward through time. This will take a little while because it's 22 days worth. Just so we have some solutions available without having to wait, I went ahead and created a solution folder here. So in this case, I'm going to abort and remove that simulation, and then just go into my solutions folder and bring in the morphology change data set, just as one example to show what that looks like. And so we have a folder now called simulation, and it's got a depth, and you see all these time steps. So these depths are through time, and then we've got a morphology change through time. And so what I can do is, let's change the colors of this morphology change. I'll right click and change the data contour options. I'll make it color fill. I'll choose basically I want to choose a magnitude difference color ramp, and that's what this is. For that color ramp, it's easier to see. You notice there's no white in here. It's easier to see the areas of zero change if you have an odd number. And we also need to make the range a symmetric range. So let's go to -4 to 4. And then you can change these values as you need to make your list show up a little bit easier. All right. And so when we do that, there's a little glitch the first time you go and look at this data set, but we can go off of that and come back, and then it shows up correctly. I've got to get them to fix these persistent bugs here. But anyway, it shows up correctly, and then we can just start scrolling through, and you see it actually is starting to dredge this area here and placing the material down here. All right, and I'm just speeding through this, and then once we get to the final, you can see the final answer here. And you notice the amount that it's taken is larger at the top. That's because the bathymetry underlying this whole area is transitioning from shallower to deeper, so it doesn't have to take as much here to get to that 6 meters deep as it did in this level. And so that's why the colors are different. And similar here, it had to place more material here than it did up there. So you can look at different data sets if you want. So this is the depth through time. So we're looking at that, and you can change the contour range to make it a little bit easier to see if you want. And then there's other data sets to be that you can look at for current velocity, transport rates, and things like that. All right, I'll keep an eye on the chat window, and I'll try to come back if we do get that any questions. So I mentioned the dredge method here. You could do a specified cell where it starts at the corner and moves outward. You could also do the shallowest cell. So if you have an area, some of the cells are deeper than others, it'll try to fill them from, it basically will just fill in those holes first, and then as needed, it'll fill in above that to a certain depth. For the triggers, like I said, we have, you can base it on depth, you can base it on a volume of material above the dredge depth. So that might be useful if you are monitoring an area, and whenever material is placed in this area, or through normal simulation, it starts filling in, then you can tell it to automatically dredge those areas as needed. So if you start out and it's okay, then you don't have to worry about it. And then once through the operation of CMS, if things start filling into that channel and they get above a certain volume or depth, then you would be able to have this feature automatically triggered where it would remove the material and place it in a certain predefined location. For percent, it's similar to the depth, but basically when a certain percentage of cells in the area, you don't want to do it just based on one cell shoaling in, but if you have a percentage that's, say, 25% of the cells are now higher than that minimum, then it could trigger it. And then you have that depth as well. You can also tell it to dredge based on time periods. And so say, and we would do this, say we know historically when a dredge event happened for a certain location, we know that we could put, okay, when that started and when it finished, and between those times, we would get the dredging occurring. And then outside of those times, nothing would be going on. So this is one way that if we are reproducing a run where there was a dredge that happened, say in November, and we started this in January, we could plan for that. We're going to make this a little bit easier, so we could put starting and ending days instead of hours from the time. But for right now, this is how it was planned out and started, and this will be improving in the next version of SMS. Same thing for the distribution. As I mentioned, there's percent that we showed, but there's also sequential. And so what that does is, instead of a certain amount for all the different placement areas, it starts in the first placement area and fills that to capacity. And if there's anything left over, then it moves to the second. And then if there's anything left over, it moves to the third. So that's one option that you can tell it to choose, okay, not just everywhere, but in order as needed, based on the amount of material you are moving from a certain location. So in the placement definition, the options, we also said, starting at a certain cell, but then you could also place the material uniformly throughout the entire area, and then every cell gets the same amount of material as the dredging is occurring, and then it goes up to a set thickness. And that's pretty much all of the options for the dredge module. and for dredging and placing material. And so I guess I thought this was going to take a little bit longer than it actually did. Is there anything that I need to go back over with you guys? Let me just go to the website real quick. So this is just the SERP website. We can look under our publications, under technical notes, and you'll find this tool. You'll find the Coastal Modeling System Dredge Module here, and that's the first iteration with single grain sizes and an example. And then there's also one this summer that's basically simulation with multiple grain sizes, and it shows that as well. For the first iteration, we actually used a real location, and that location was right here, St. Mary's entrance. And we took material through the channel and then placed it offshore. So this was a real site, a real dredge event, and we tried our best to model that. So all of this information is contained in each of these tech notes, and if you need any other information on that, these are available. As I mentioned earlier, there will be an additional functionality to SMS 13.1, which should be coming out, I guess, in the next 2 months or so, sometime this fall. And basically, it's a similar operation. We've tried to keep them relatively consistent, but instead of where this defines where a dredge event will happen during the middle of a run, the other tool will basically help you set up various alternatives that will be distributing the sediment into different locations. So like one of our projects that we had with Merrimack up in Massachusetts, we had 10, 12 sediment management alternatives. So we would take a certain amount of material either from the flood shoal or the ebb shoal, and they would place that material at various locations as beneficial to those communities. And so it took a lot of time getting each one of those alternatives set up. Well, we've developed a tool with SMS 13.1 that will help automate that, so you can plan these things in advance, and it actually creates more exact volumes of material, and it also tapers the edges and makes sure that you're not violating slopes too much, and then you're ready to go. So we'll be showing that at a little bit later time, but those are all set up to where you would start each one of those from the same time point. It's not really scheduling or planning for a dredge event to happen within the course of your run. It's starting with a set different alternative that's different in a sediment management way than other alternatives. So it's a little bit different, but they are similar, and so we'll be covering that in the next fiscal year, sometime probably starting after Christmas in the springtime. We may get together another webinar and show a little bit of that. Definitely not a week-long thing, but maybe a case-by-case basis. So